Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about DAC, that is Digital to Analog Converter interfacing. So this DAC, how it interfaced with the microprocessor to get the inputs. So first thing, what is need for DAC? So real world signals always in analog, but whenever we need to process and store, so we need to convert into digital. After processing or storing and whenever retrieving, again we need to convert back to the analog for playing or using that. So whenever you are using an analog signal, that will be connected to the microprocessor, so we need to convert an analog to digital in the input side. Similarly, output side, this digital should be converted into analog. So that's why we need for an ADC and DAC. So here we are going to see about DACs. So DAC, it is an digital to analog converter. So this will be interfaced with the microprocessor to convert an digital into analog. So we need to connect this address bus, data bus and control lines for an effective communication between them. Look at the block diagram. Look at this. So this is the address lines. So here A0 and A1 is connected. Remaining A2 to A7, that will be connected to OR gate and that given for a chip select signal. So look at this. This is an address bus and data bus. So the data bus D0 to D7, that will be connected here. Read write control signal will be connected here and reset, and address bus A0 and A1 will be connected here. So these two will be for selecting the different channels. Look at this. So this is an actually 8255. So 8255, we have already seen that programmable peripheral interface. Whenever we get an input, that should be connected to through this 825. So both input and output, we use this 8255 to communicate with the microprocessor with that IO devices. Look at this 8255, it have three ports, port A, port B, port C. So here we are using a port A. Look at this, port A, PA0 to PA7. This will be connected to this A0 to A7, or we can say it's an A1 to A8 or A0 to A7. So this is 0808 DAC IC. So it converts this corresponding digital to analog. So in terms of current only we get, so we need to convert from current to voltage. This is the I to V converter. So we are using an operational amplifier. Look at this positive channel is connected to ground and negative, this current will be connected here. We have the feedback resistor 2.5K and this potential divider also. So this is the reference voltage that will be connected here. So based on this input configuration, so we have an 8-bit now, so that means 80 to 81. So corresponding value will be given. Depending upon that, then the actual value, so if you take a 0 to 5 voltage, this 0 to 5 voltage will be varied. So here, depending upon the weightages, that is LSB have a least weightages and MSB have a higher weightages. So depending upon the weightages, the resistor will be connected and that corresponding value will be summed up and get in current. That current will be converted into voltage to get that final output. So look at this. So based on this configuration, we get only one thing. So if you take this value will be varies from 80 to 81. That is, if it say it's an hexadecimal, it will be 00 to FF. Or if you say it's a decimal, it will be varies from 0 to 255. Depending upon this 0 to 255, that voltage will be getting. So how we get means, so for example, if you take a 5 voltage multiply with this corresponding value, so from 00 to 255 divided by 256 is an actual values. So it will varies this value 0 to 5 depending upon this configurations. So here this address will be selected based on this. So here look at this OR gate. So OR gate will be given this chip select. So this is an active low logic. So whenever we get a 0 here, this chip select will be enabled. So if for an OR gate, the output will be 0 only for the combination all the inputs are 0. Remaining all cases, even one input is 1, output will be 1. So only one combination that all the inputs are 0, the output will be 0. So that means from A2 to A7 must be a 0 to enable this chip. Again this A0, A1, that will be selected. We have 4 combinations 0, 0, 0, 1, 1, 0, 1, 1 that select that particular channels. So selecting DAC, so choosing the DAC will be important. So depending on the application we can choose it. So we can use a DAC 0808 or a 0800 or a serial DAC such as DAC 8551 or DAC 8552 that will be used. Depending upon our application, we can select the DAC. Second one, address decoding. So address decoding is most important one that decides that which address to be used, because each IO device will be separated by this particular addresses. Next will be a data bus connection. So the bidirectional data bus will be connected to the internal bus with this microprocessor to communicate the datas. So address bus connection, so it connects this address bus from the microprocessor to the DAC unit. So VA0, DA1 will be directly connected and remaining will be connected through some logics. Depending upon the logic, the address will be varied. So control signal connections, so control signal like a read signal, write signals, these signals from microprocessor, it should be connected to the DACs. So power supply, to operate the chip, we need the power supplies, that is 5 voltage and ground, that will be connected. Clock signal, if required, we can clock signal will be connected from a microprocessor to DAC unit. So programming, we need to have a high level language C, or we can use an assembly language to program the microprocessor to send the values to the DAC ports. So data processing, it converts the digital output, will be converted into analog, and that will be given to the output of the device. Thank you.